Okay, so hello everyone. I'll be talking a bit about our project, which is about assessing some sedimentary deposits in southwestern Montana and uncovering any aeolian signature if there is any. Aeolian deposits itself are a very important resource, which have proved to be a very important resource for understanding past climate and the environment. So that is basically the motivation of our project here. Alien deposits such as the Chinese Lost Plateau has been extensively studied for this reason, and we are particularly looking at uh, older Lost Plateau. With a previous study, which has suggested there is an older Lost Plateau about 30 to 40 million years ago that existed in uh, so not the northwestern United States, particularly in this region marked over here, and we are focusing on one basin here, which is the Sage Creek Basin. Now, this basin was studied previously for understanding tectonic processes within the Cordillera and the North American and the Pacific Plate. However, while doing field work, we saw that a lot of the beds right there had typical aeolian qualities as well as its proximity to the already present lush outcrops in North America, such as this wagon bed spring outcrop, suggested that aeolian deposition could have extended all the way up to this Creek Basin over here as well. Uh, Hence, we proceeded with this project uh, about. So we are looking at deposits about 40 million to about 25 million years ago within the Sage Creek Basin, within the Renova formation of the Sage Creek Basin, and we have different members, which is essentially names given to particular sedimentary deposits that can be identified in the field, ranging all the way from 48 million years of the Sage Creek member to 25 million years of the Blacktail Creek member. Now, and while doing field work, you can see some field pictures right here. These characteristics are very typical of aeolian deposits. There's massive silty deposits right there, which is uh, in contrast to the previously suggested riverine environment of this basin, which existed about 30 million years ago. So therefore, we conducted firstly some lithophysis analysis, which is to understand the depositional environment and of the different horizons. We uncovered we had both low energy floodplain and high energy fluvial channel deposits. We divided the samples we already collected into these two deposits and further into floodplain fines, paleosols, and sheet floods for low energy environments, as we thought this would be the best case for alien signatures to be uh, preserved. So we conducted grain size analysis, and we also contrasted this or compared this to the actual loss that was present right here to the grain size spectra. As you can see from the two present when I do it side by side, the two have very different uh, spectra patterns. However, we can see that there are still signatures of this loss pattern present in these different as well as the channel deposits all across the basin. However, since it is a combination of fluvial and aeolian processes, the signature will be disrupted by riverine processes as well. So therefore, to understand it better, we did an n-member analysis of these curves, and we found these three n-members which would fit all the curves, including the fluvial, the high-energy channel, as well as the lush deposits pretty well. Uh, and we further plotted the data to try and uncover some truths about our Sage Creek Basin on whether there is an aeolian deposition at all. The first thing we observed is the LUS itself had an abundance of EM1 and EM2 members, which is also present throughout the Sage Creek Basin. Now, this suggests that these are the aeolian signatures or grain size signatures of aeolian deposits, and we have similar deposits in the Sage Creek Basin as well. Alongside that, we have the EM3, which is particularly present in the Sage Creek Basin. We outlined this to be our fluvial signature from the riverine deposits, and it matches well with the when we plot the different plots for the different members. We see that the mostly the EM3 is present in the paleosols right here, which is from the Sage Creek member as well as some of the lower Dell. These two are the early Middle Eocene members, which are particularly fluvial, and as we go into the upper beds, which, like I said, were showed more aeolian characteristics, we see that there is a decrease in those members right there. So that this is now just a preliminary pilot study, and further work will be done on quartz morphology to see whether actually there is an aeolian signature. So if you're interested in this, feel free to come across my poster in on the presentation day, and I'll be happy to go into a little bit more in depth about it. Thank you.